In addition to using a wireless mic for speech reinforcement, what other microphones might we use? For those at a fixed station where the mobility of hands is essential, such as a podium or desk, you may opt for a tabletop microphone. Gooseneck microphones also fit this mold. These type of microphones are available in dynamic and condenser configurations and allow for the user to speak directly into the mic while rejecting other sound sources, reinforcing excellent clarity of speech. Boundary layer microphones can aid when it is not possible to speak directly into a mic. These types of microphones can be beneficial in applications such as conference rooms, courtrooms, or houses of worship where a discreet-looking mic is needed. Many boundary layer microphones are omnidirectional, but you will find those that have a cardioid pattern which can be nice for an altar. Another purpose for boundary layer microphones are for ambient noise compensation applications. This is where a microphone is used to listen to the ambience of a room and automatically adjust the level based on the amount of ambience. We'll explore this idea more in the commissioning curriculum. Lavalier microphones, sometimes referred to as tie-tack microphones because of how easily they can be affixed to a garment, are extremely small microphones that can use either an omnidirectional or cardioid pattern. These are typically used in television broadcasts, but are also a great choice for lecturers who want the freedom to move about a stage and use their hands. They are typically connected to a body pack that transmits the signal to a wireless receiver. Lavalier microphones can also be permanently installed into a ceiling to pick up sound taking place in an environment. Think of our distance learning classroom where we want the students conferencing in to be able to hear what our local students might be saying. We may opt for installing lavalier microphones instead of tabletop microphones for a number of reasons, such as to free up desk space, reduce ambient noise such as paper rustling or keyboard clatter, and to prevent accidents such as a drink spilling into a microphone. Similar to lavalier microphones, you will find small ear-hook microphones or head-worn microphones. These too can also promote freedom of movement. These particular options can reduce the chances of a mic picking up on garments moving, such as a suit jacket potentially getting in the way of a mic affixed to a tie. There are many other microphones to be considered, and we haven't even touched on microphones that can be used in live music and recording environments. Our focus, if you haven't guessed already, has been on speech reinforcement. Ultimately, what are we trying to accomplish when we spec a microphone for speech reinforcement applications? Well, we need to account for the following principles: adequate and uniform speech signal levels, adequate speech intelligibility, natural speech quality, and stable performance under all operating conditions. Let's take a look at some scenarios before the advent of microphones and loudspeakers. Acousticians needed to figure out how to get a person's voice to the entire audience. We quickly see a history of lectures moving from the outdoors to inside. Figure 1 shows a single level for both the talker and the audience. As you can see, the talker's voice falls short and cannot reach the back. Likewise, Figure 2 sees the talker elevated above the entire audience. Compared to Figure 1, this is a better approach, but we still fall short. Figure 3 sees the audience staggered in rows in a type of amphitheater. This allows for the talker's voice to have better coverage across the audience. Now in Figure 4 we have walls and a ceiling. Early reflections can help to increase the sound level and intelligibility of the talker. And finally, in Figure 5, adding a reflector behind the talker boosts intelligibility at a distance. Unfortunately, rooms are not always designed to reinforce acoustics, but we can at least now amplify our voice through the use of a microphone and speakers strategically placed throughout a listening environment. We decided in the signal management video to use a lavalier. In order to account for the instructor not placing the lavalier mic appropriately on themselves, mic facing mouth about mid-chest, let's use one that has an omnidirectional polar pattern. We also need a wireless body pack transmitter and a wireless receiver. The AKG WMS 4500 CK77 set fits the bill on all fronts, providing you with a CK77 omnidirectional lavalier mic, an AKG PT 4500 body pack transmitter, and an AKG WMS 4500 receiver, which proves extremely easy to set up. For a stationary option, the AKG CGN521STS is an excellent gooseneck microphone featuring a cardioid polar pattern and a 50 cm long gooseneck, allowing the instructor to talk into the microphone from a number of angles. It also features a built-in LED to provide microphone status, as well as a programmable switch allowing the instructor to permanently turn the mic on or off, or allow for a momentary on-off function. For the student microphones, we want to free up desk space and prevent any unwanted accidents, so let's install boundary microphones in the ceiling. Accounting for discreteness, we might want to consider a smaller microphone. The PZM-10 from AKG is small and can blend in with any environment. Just make sure the DSP or mixer you are connecting this mic to has phantom power, seeing as this is a condenser microphone.